Yes.
Recording is on.
Yes, please.
Okay, thank you. Now I want to share my desktop, and maybe now, okay, now I think you can see me.
Yes, yes.
Okay, thank you. So I will talk today about AI for network analysis and prediction. Uh, Network science or network analysis nowadays, I think more people also interested about this network world. Let's say what I want to talk today about network analysis and prediction related to complex network. The first question: why a complex network? Say I think if we talk about around us in our life, we could say everything can be modeled as a network, or a lot of data set, or a lot of relationship in our life related to network. Say social network. Nowadays, I think like me, I'm in Indonesia. Mostly people they play like social media like Twitter or now as X or Facebook or let's say Instagram. So the social media, social network now become massive everywhere, especially for Indonesian who are they use this kind of social media uh, in intensive way. So social network, this is also network. I mean, in our life, social network could be one point or one problem or one subject which is we are might to be involved in it. Second, let's say social network, the first one. Second, let's say economic network or say financial network. Company or bank, they make transaction in their field. I don't know what kind of transaction they made, but this financial transaction could be modeled as a network. Then the economic network, what I used to work with my data set during my PhD studies, I used to write two papers, and the data set about trading between countries in the world. So about 207 countries in the world, they trading 96 commodities, and we model it as a network. And network analysis and prediction in this area. Also, this is in economic, this is something that related to economic growth of the country based on the information from this network. Of course, there's also communication network like telecommunication or wireless communication, whatever. We could model also as a network. So analyzing the network and the possibility of failure of connection between telecommunication devices, this is also interesting area to analyze and predict. Another thing, let's say citation network. If you are a scientist, you work at the university or a research institution, then you publish the paper. Every time you publish the paper, you cite other papers. So when you cite other paper, cite any other paper, let's say from mathematics or computer science or from social science or from medicine, you publish the paper, of course you will cite the paper. So citation network, this is also exists and special research about the citation network out there. Another thing, let's say network of neuron in biology or brain network. So network of brain, they do analysis about connection or let's say connectomic, the relationship between one neuron and other neuron in brain now also increase. I mean, the pay attention research in the subjects now become larger. And Another thing, let's say in biology or in chemistry, let's say biology, they have molecular biology, or let's say in molecular chemistry. In biology, molecular biology, they have like a network protein or network of gene, let's say. But then, let's say in network of chemistry, the molecule is also network, and the molecule, let's say, yeah, I mean the molecule of drug nowadays, drug discovery, they use network theory, analysis, prediction, and then they use AI how to find new drug. This is kind of biology, chemistry, and a lot of subject could be model as a network. That means network is everywhere. Network may be in all aspects of our lives. That's why the topic about network analysis and prediction become more interesting. So this is real world about network. But say I made a very simple description of the fiction about the network. Let's say you have complex network, but here you see uh, the circle with white, some are small, some are larger or bigger, and there is a link between the node or the point. So this is kind of different node or different important of the node, different important of, let's say, in social network, man or human, and the link between those people. So this kind of, let's say, anatomy of complex network. But then let's talk a bit about network theory, because I'm sure not all of people here, mostly I heard, because Masud was asking me to give a talk, which is the audience might be or mostly coming from general people who not coming from mathematics or not coming from computer science. So I need to talk a bit about network theory fundamentals. So let's say we have node and links A, B, C, which is A, B, C, our node, and the connection between those node we name it, or we call it as a link. Or in mathematical theory, network science or network, we call graph theory, which is in mathematics, graph consists of vertices. Vertice is node in network science. And then the link between vertices we call edge. So there is a node or link, node and link, but there is also vertice and edge. And the key concept inside the network or in graph theory, we can see degree. What is degree? Degree is link or edge between node. Let's say A connect to B, B connect to C, C connect to B. So A having 2 degree, B having 2 degree, and C having 2 degree. So based on the link. But there's also path or sequence of link. That means if one node to, let's say we have a 10 node from 1 to 7, let's say, it come or it has link connection, not directly, but let's say from 1 to 3, 3 to 5, 5 to 7, let's say. So this is related to sequence of link, and we call path. And then this is popular clustering. Clustering, that means grouping between the grouping of the node in the network or in the graph. And then centrality. Centrality is to find or to know, let's say we have the network, to know which one the most important node in the network, which one is the most important role in the network. So we call centrality. But the centrality, we have different measure of centrality, let's say closeness centrality, between centrality, degree centrality, pegang centrality, and the others. So not only one measurement of centrality. Then the application, of course, as I mentioned earlier, there is social network, biology or neuroscience, or let's say chemistry, molecular drug discovery, or in financial network. So those things related to network theory fundamentals. I mean, this is of course very basic. Yes, now we see this is mathematical foundation of network analysis. Yeah, let's say clustering. Clustering also we call community detection is very popular in the past. Name is Loven method. Loven method here like this, but nowadays there is Leiden method. After Loven method very popular, but now Leiden method. But what I mean in this picture, in this slide, is I want to show you that behind the complex network theory, there are mathematical formulation, which is this is only sum of measurement, which is the mathematical formulation. Some way, at some point, is quite complex. But I mean, of course, I will not talk more about mathematics, but behind this complex theory, we have a lot of mathematical formulation. Okay, I will start to talk about. Okay, that one is my, let's say, my open up this talk about the network theory. But now I will talk. I will start to talk about small word network. So small word network. This is we can say, yeah. I mean the world indeed is very small based on network science, and one network, or let's say in one cluster, in one group, or let's say in high cluster like cliques, then we connect to other node. But connection from one node to other node we call as path length. And then maybe let's say in Facebook or in X, we have a friend, and our friend also has a friend, and friend of friend, and so on. But in the small world, one man in the world could connect to all other people in the world by 6 degree. What that mean by 6 degree? Only by 6 connection, by 5 connection to the 6. Let's say this is to make it a bit more clear. Let's say we have close neighbor. You have a friend in Facebook, let's say, or I don't want first on Facebook, but let's say in our society, we had a friend, very close friend, but our friend has a friend or another friend, but his friend might be work at let's say, I don't know, about software engineer or scientist in Europe. Now I'm in Indonesia. Then his friend in Europe also has a friend in US, let's say, and his friend also having friend in let's say in Middle East. In this context, one to the other, in small word theory and 6 degree of separation, one man or one person could connect to all other person in the world by only 6 degree. That means we, I'm in Indonesia, could connect to all other people in the world only by 6 degree of our friend. Even here, Facebook, of course, now it's Meta. I mean, mostly in Indonesia they have account at Facebook. This Facebook, they have not 6 degree. Even they have fewer. Even they have only 3.5. So one user ID in Facebook could connect to all other online friend on Facebook only 3.5 degree. So what does mean in small word? Then we are, let's say, it's easy to reach other people on this earth wherever. So this kind social network could connect everyone and everywhere. Now I will talk about, because that's about network or network science, about complex network. Now I would love to talk about AI, because the topic of my talk related to AI for network analysis and prediction. And AI in my case, because AI has subset, the subset is machine learning. And subset of machine learning is deep learning. So part of AI is deep learning. And what I want to explain about GNNS is deep learning for analysis and prediction. But GNN, that means gap neural network, this deep learning special design for gap data set or for network. So the topic AI for network analysis and prediction at this point, because there is also related to NLP and the other stuff in machine learning or in deep learning, but I will more talk about GNN as a gap neural network machine learning for network analysis and prediction, because it's related to analysis and prediction about the structure of the node or structure of the network. And this is nowadays, I think, is quite popular and yeah, become prevalent. I mean, everywhere they try to implement this method. So the theory of GNN, gap neural network, there is message passing. So when we have the network, this machine learning try to learn one node, learn from other node, but then each node for its passing or its hop, each step. So the node aggregating or collecting information about all other nodes. And then the node in machine learning try to understand the neighbor and then try to understand neighbor of neighbor. So this is very popular, I think. And then there is aggregation function, this to collect information, embedding space. Then there is node embedding, edge embedding, because node or vertex, node embedding, and link embedding.
Asap, you are muted again. You are muted again. We cannot hear you.
Now it's okay? Now it's okay?
Yes.
Hello? Okay. Okay. So I don't know. I don't know why. Okay, I will continue. At GNN, there is node classification and link prediction. Node classification is to classify or to cluster node based on the learning from the information from all other node, and link prediction to.
You're muted again.
Asap, you are muted again. We cannot hear you.
Yeah, you can hear me now. I don't
Yes,
know
now
why.
I can hear. Yes.
I don't know. Okay.
Yeah.
Now it's okay.
Yeah. So then, actually,
Okay.
one of the
First,
audience said, "Okay, don't press the space bar." Probably could be because of the space bar. Yeah.
I don't. Yeah. Okay.
Yeah.
First, I will talk AI in social network. So this predictive analytic, let's say we talk about fake news detection or rapid spread of fake news or hoax, because nowadays in social network like Facebook or X, there are a lot of fake news. So AI in social network to define the, I mean, to define or to cluster or to detect the fake news. But then also the polarization, say nowadays, I don't know, nowadays, let's say one issue in Europe or one issue in the world about the US, let's say, or whatever, but then some people support one side, another people support another side. Then it's like polarization between both topic, let's say topic in social network. But then we need to analyze what is could be the point or the user ID who are amplified the information become larger polarization, or let's say echo chamber in social network theory. And nowadays very well, I mean, everywhere. And this AI to implement this, let's say, with the theory of the theory of polarization, now also increase. I mean, how to solve this problem. Maybe I couldn't talk more about this. I still have about 10 minutes, I think. And then still, let's say this is predicting polarization. And let's say GNN, other AI, let's say, doesn't just look at individual force, but GNN could look at the geometry in terms of geometry of social network. So what is geometry? So GNN could look at all information spread in every node. And that's why this GNN now also implement for this polarization. And then GNN detect tightly connected group where information circulate. Because let's say we have 1 million node or 1 billion node in Facebook. And for one issue, GNN could see to which node are or to how many number of the node this issue coming. I mean, the node catching this issue, how large. So GNN could detect, could read about that because GNN could see as geometry of social network. And then let's say, of course, like and dislike also in this polarization. This, of course, this I think this is not difficult task, it's easy task, how to predict, how to group by node classification as a part of GNN. So this kind of polarization, yes, of course, I mean AI in network analysis implement. Now, detective of misinformation spreader. Actually, this is my expertise and my work. I have 3 papers about this, and then this is misinformation spreader. How GNN could predict people are belong to misinformation or not misinformation. Let's say, in very simple way, we have 100 people, 50 people, 20 people, let's say, 20 people are labeled as, or 10 people labeled as misinformation spreader, and 15 people labeled as non-misinformation spreader. And we want to detect or to predict the rest. So 75 belong to misinformation spreader or not misinformation spreader. So GNN could do this in let's say, could do this in very easy way based on node classification and semi-supervised learning. Then another thing, in this misinformation spreader, that might be, let's say, we could also try to find when we have a flag or we have a label who are misinformation spreader, who are not. Let's say from who are misinformation spreader, we want to know who are really aggressive in spreading misinformation. So again, this GNN could solve this problem. What that mean? The AI to detect misinformation spreader, to find who are the aggressive misinformation spreader, also could solve with AI application. So I mean, AI in social network implement for a long time, and nowadays more, especially combining with graph theory and natural language processing or LLM, large language model nowadays now increase. Uh, Now I will talk a bit about gap for financial data. So financial data is inherently relational. So that means relational. That means one connect to the other. That means we could also model as a network. Traditional model treat transaction as independent, but then GNN model relationship directly. And when GNN could model the financial network, then finally, of course, it could implement node classification and link prediction. Or next, I will talk a bit about anomaly detection on, let's say, this financial network. But based on node classification and link prediction, this method could be implemented either by semi-supervised or self-supervised learning, can implement for fraud detection and money laundering. That means now machine learning, of course, could detect this fraud detection and money laundering. And now they, of course, let's say usually they need the constraint, like they need it very fast, let's say online, very fast, in minute or in hour. Yeah, I mean this GNN or AI now they could implement for this task. But let's say how message passing in this financial network analysis and prediction. So let's say one node having connection, and then this node could aggregate or collect information from neighbor and neighbor of neighbor. And of course, in modern society or in modern technology, network more and more complex. And then network with attribute, a lot of attribute or a lot of feature in the node, this is not easy to define. But then GNN with the capability of message passing for each layer when it has learning. So message passing, that means aggregating, passing information from other node to specific node. So all the node could learn any other node and then could do, yeah, I mean exact or robust prediction. I have no time to. Okay, and then this is also similar, I think, about fraud detection and money laundering. But then I will talk about a bit about financial anomaly detection. Let's say I have one paper, so we could do analysis and predict or find the anomaly in financial network.
I think also there is a you have connection issue.
But then I had one paper. So first is to do learning or do training, and then the result of training we could say node embedding, or we got the result of node embedding, and the node embedding we could do node entropy to find anomaly. So anomaly could be used GNN as a tool to node embedding and find node entropy. But then also we could do anomaly node directly inside GNN architecture. Let's say now there is also beta wavelet GNN. This method could implement specific for anomaly detection in financial network. So I mean, a lot of method and theory used to find some fraud detection and money laundering. I think only 5 minutes. Now I will talk a bit about GNN in network medicine. Again, why network? Why graphs? Biological entities also having a relationship, so it's relational entities, and then might be, let's say in biology, protein.
I think also there is again the connection issue. Mm,
also as a network and doing analysis and prediction, this could be implemented at this topic, at this subject. Say we want to find or to predict or to analyze disease, let's say this is analysis, then let's say but based on the protein of the protein network, then we could say some node with specific protein having special disease. And based on node classification, we could predict people with, of course, their protein, with people who has specific or similar or similarity of the node or similarity character of this node. And this GNN implement in this nowadays massive in biological, especially biological molecular biology or in bioinformatics. And I think this is more prevalent and quite interesting. This also implement for gene network, at least by those things related to prediction, how to find how to get node classification and to find a link, something as a result of prediction that might be lead to finding something really advanced in let's say in medicine nowadays, especially nowadays at hospital or let's say a hospital or in medicine. Nowadays they try to develop precision medicine. The precision medicine, that means the medicine specific design for special people, could be defined as precision medicine is the medicine designed for specific people or specific person. That means to decrease the number of effect, and the way of designing this medicine, they of course they did this prediction at the first step, and then they could design specific drug for these specific people. Masood, I think now I have already 30 minutes.
Okay, so great. Thank you very much, Asap, for your talk, and it was very interesting. So you covered the different like part of using the AI in the complex network analysis, and so now if there is any questions, so we can ask Asap. Already I have one in the chat box. If we transit from human institutions, governments, international bodies, to AI driven systems like GNN to act as the oracle for truth, can we leverage open source software, philosophies, and decentralized consensus to prevent the silicon overload? Scenario, and to what extent are platforms like Facebook already implementing these structural blocks?
Wait, can you make it? I mean, in concise sentence.
Yes. So maybe we can, Tori, if you can please repeat your question.
I was just wondering about Facebook, for instance. Do they have like AI-driven oracle or agent that is kind of looking into what is fake news
No, yeah,
or not, and blocking people automatically?
yeah.
Do you know?
Okay. This is that mean if we found fake news and directly could block the, let's say, the user ID. I mean, who's spreading the fake news, something like that.
Yeah, correct. I mean, Is it automated today?
Yeah, uh, to do that, to find, to block some people automatically is okay, but then how to define some news is really fake? This is need more. Like more special uh, check for many points. This is also not easy because to define this is fake or not, this is also need some different step to exactly define it. I think theoretically, of course, this is possible, but then to define that fact or not, this is not easy.
So then basically, we don't have already like a tool to can detect fake news or something. We don't have it yet.
In my research, no, but other research group they have related about this.
No, I mean like in the industry, for example, they're already using it. For example, like Facebook. Do you know that Facebook already using any tool to stop the notes that they are doing?
But Facebook also when they stops someone or block someone, they need like a report, not directly,
Not directly.
except special sentence or word really extremely bad.
Mhm, okay, yeah. Yes. And if there is any other question, please. So I have one. If there's, so actually I have two questions. So I just um, basically ask in one. It has two parts.
Yes.
Which type of problems actually we can model it as a complex network analysis, or any kind of problem can be just modeled as a complex network analysis. And then if someone wants to start like using the AI in the complex network analysis, so what is the starting point? I mean, like, do you suggest any tools or something that it is available, like a software, open software that we can use it?
Yeah, there are uh, um, there are some software related to network analysis, but then if you have specific problem, of course you need to implement. To implement specific method as well. So if you work with this network, there are some software, but then if you have specific problem, then still you need to have your own architecture, let's say.
But can you please introduce if there are some already famous and open source that everybody can use? For example, for GNN in the like using in the complex network
Uh,
analysis.
yeah, but the GNN is software. You work with GNN in, let's say, in Python mostly. Then you design it, but what I knew about GNN and is already, ready to use. I don't know about this now. GNN, so you can use directly. In specific architecture, and then you can do for a specific problem like in financial and social, based on this GNN. I don't know about this right now.
Okay, so I don't know if there is any other question. So, but Asif, can I ask you that maybe later, if you have any tools you remember later, I can later post it on the or LinkedIn community,
Yes,
the
sure,
tools. Yeah,
sure.
then the people can access, and then if they need,
Yes, sure.
they can use that. Or maybe work with a short introduction, so we can have. Yes. So, if there is any other question, so please. Is there any other question? Okay. Okay. So it seems that there is not any other question. So I stop sharing